primate species are intelligent. Some use tools, others show self-awareness, and they're good at problem solving. Most live in social structures and family groups. We are primates. When justifying experiments on other primates, they're referred to as the non-human primates. Yet these non-human primates have proved themselves capable of learning rudimentary arithmetic, have demonstrated reasoning. Some have even learnt to speak in human sign language, and they display similar emotions to us, such as affection, anger, and sorrow, even empathy. But to argue that our similarities justify their use in laboratories is to ignore, at our peril, the fundamental biological differences at the physiological, genetic, and immune system level, which are so important to the outcome of any experiment. But whilst small differences in DNA can make huge differences in experiments, we are close enough to comprehend the suffering of our fellow primates when they're snatched from the wild, when caged, confined, transported, when restrained, injected with drugs, force-fed chemicals, deliberately brain damaged. We know they suffer. We know they suffer, as we would. Yet despite this, and that more sophisticated alternatives to animal experiments are available than ever before, the number of primates being used in experiments around the world is rising. Over 10,000 primates will die in European laboratories this year. In September 2007, members of the European Parliament adopted a written declaration calling for an urgent end to the use of apes and wild-caught monkeys in scientific experiments, and for a timetable to replace the use of all primates in experiments with alternatives. This reasonable demand must be implemented, whether it is for compassion, conservation, to maintain and enhance developments in science, or for human health. Chimpanzees are so close to us genetically that some scientists have suggested they be reclassified alongside humans. But history shows that this close family connection is not close enough to provide the precision necessary for modern biological research. The rush in the USA to conduct AIDS research on chimpanzees proved a costly failure. Steadily, the world has abandoned the use of apes in experiments, leaving the USA isolated, with an estimated 1,300 laboratory chimpanzees, and breeding now stopped. Chimpanzee experiments can end today, without exception. A quarter of primate species are threatened with extinction. Yet as governments make desperate efforts to prevent the poor and hungry eating some species to oblivion, the Western research community demands the right to take these species for unnecessary and unreliable experiments, when alternatives could be used instead. In the South American forests, trappers search for owl monkeys, which will be sold for malaria experiments in Colombia. Once located, the trappers climb the trees and net them to ensure that the monkeys cannot escape. Trappers are typically local people meeting the demand of laboratories. They're not recruited with conservation or welfare goals in mind. They are simply the cheap labor that is able and willing to catch monkeys. The frightened monkeys are torn from the trees, their freedom, and families. Their forest is replaced by the barren, factory-type conditions of a laboratory, and some are put into isolation, torture for a monkey. With an estimated 10% of primates in EU labs coming from the wild, and many more from wild-caught parents, good intent has not been enough, and a clear prohibition of this cruel business is desperately needed. Whether wild-caught or captive-bred, the majority of monkeys used in Europe are imported. They come from China, the Philippines, Vietnam, Indonesia, Mauritius, Kenya, Israel, Guyana. These long journeys mean the animals are severely restricted for extended periods. This laboratory monkey supply facility in Spain is simply a doorway for monkeys from Mauritius, where the French owner is known to supplement its breeding stock with wild-caught animals. The majority of primates brought in to feed Europe's laboratories are referred to as F1, offspring born of wild-caught parents. Only the prohibition of the F1 animals will put pressure on suppliers not to regard the world's wild monkeys as their own resource to harvest. And what of the living conditions with these suppliers, thousands of miles away across the globe? This is Napo Valley in Vietnam, well outside the jurisdiction of the European Commission, Parliament or member states. Located just outside Ho Chi Minh City and with offices in Hong Kong, this is a huge exporter for monkeys to Europe and the USA. Behind high walls, high security, and an initially smart exterior, we found monkeys in small pens. But then, we found these monkeys. It's hard to imagine a more miserable and desperate existence for these intelligent social animals. This is a major supplier of monkeys to the UK, despite government claims that, in effect, we will only allow the use of animals from overseas centres we believe produce purpose-bred animals to acceptable welfare standards. In 2005, this site was assessed by the UK's Animals Scientific Procedures Inspectorate. The visit identified shortcomings in animal accommodation and care. The centre was notified that its status as an approved centre would cease once all existing orders for primates had been filled. However, by the end of the year, the inspectorate had received reassurances and evidence that significant improvements had been made. Napo Valley continued to supply animals to British laboratories. In 2007, the UK government confirmed that the site had not been visited since March 2005. This ADI footage is from November 2008. European and US laboratories ensure these monkeys, described as the macaque species least able to respond satisfactorily to transport, are crossing the world. Batches of 60 monkeys at a time were sent from Napo Valley to Huntingdon Life Sciences in the UK. The monkeys were flown from Ho Chi Minh to France, then taken by road to England and to Huntingdon Life Sciences in Cambridgeshire. Staff understood the journey took about 30 hours, with the monkeys severely confined and alone. Most monkeys arriving in European laboratories are used in the type of commercial testing that is carried out at Huntingdon Life Sciences, or HLS. HLS is contracted by manufacturers of pharmaceutical, chemical, and other products to perform tests on an industrial scale. HLS keeps around 500 macaque monkeys to be force-fed, injected, or made to inhale test compounds. This is one of the most secretive areas of animal experimentation. These experiments are not scrutinized in advance by regulators, and such experiments are rarely, if ever, published. This ADI investigation gives a unique insight into how these monkeys live and die behind closed doors. Monkeys arriving from Vietnam are placed in stock colony J06. Up to 15 share a room little more than 2 meters wide and tall by 3 meters long, with a small catching cage. Remember, these are animals that naturally live amongst trees in large troops of 50 to 100 animals and can travel over 1.5 kilometers in a day. Their HLS home provides an average of 1 cubic meter per animal. The monkeys are moved to Unit M12 for experimentation. Some are kept in cages of roughly 1 cubic meter. 3 of these may be linked, with 3 monkeys sharing, their rich, natural habitat now replaced by a single horizontal bar per cage. UK regulation acknowledges primates have high intelligence, most have arboreal habits, and all need complex, stimulating environments. the failure of regulations and the gulf between how welfare is perceived inside and outside of laboratories is apparent. Monkeys that escaped had nowhere to run to and might be attacked by others. Monkeys were injured on cages and by cage mates. A blood-stained animal lost his toes, either severed by caging or he had chewed them off himself. In an afternoon, monkey 417 almost chewed off a finger, gnawing through bone. A female injured her face so badly she could no longer eat and required force feeding. Others suffered diarrhea, nosebleeds, or ate and then vomited their own excrement. Then it is testing time. Tests involved anything from 4 to 72 monkeys. It takes 3 people to dose a small monkey by mouth. The catcher pins the animal's arms, the legger takes the legs, and another feeds a rubber tube down the throat to the animal's stomach and pumps in the test substance. In other tests, the monkeys are strapped down in chairs. For some, the stress is so great they suffer rectal prolapse, a known indicator of gross stress in restrained primates. Sometimes several monkeys would prolapse, and some individuals would prolapse repeatedly. During an inhalation study licensed as mild, 3 monkeys died or had to be killed due to partially collapsed and blocked lungs. 3 others collapsed but were revived. A necropsy showed the animals had blackened lungs. In the wild, these monkeys innovate and learn from each other, passing on skills and knowledge such as cleaning food or fishing. What do monkeys who peer from their cages think as their companions are strapped down for experimentation? And what of the animals tested upon month after month? Some monkeys had an incontinence drug pumped into their stomach every day for a year. Others were bled multiple times in a day, or day after day, enduring over 80 bleeds. On the days when animals were killed and necropsied, the other monkeys would fall silent. The results of these tests are known to be affected by the stress and fear experienced by the monkeys. And then there are the impacts of the experiments themselves. Documents leaked from another contract testing laboratory, Inveresk in Scotland, show that during tests for an asthma drug, monkeys suffered with liquid feces, redness of face, lips, feet and hands, swollen penises, low heart rate, hernias, body tremors, and a quiet, hunched appearance. It doesn't have to be this way. Scientific and technological advances are forging ahead, creating fast, accurate, non-animal techniques which provide data directly applicable to humans. They avoid the differences between species which make outdated animal experimentation methods unreliable. For example, gout is caused by excess uric acid, which is produced in monkeys, apes, and humans, but only humans get gout. Monkeys can carry herpes B virus without suffering the disease. In humans, the disease is rare, but almost always fatal. Studies have shown that effects of compounds in humans differ from those in laboratory monkeys on average a third of the time. Such differences were illustrated when the UK trial for test drug TGN-1412 was almost fatal to human volunteers who suffered multiple organ failure, soaring body temperatures, dilated blood vessels, falling blood pressure, swollen neck and head, limbs turning purple, permanent damage to immune system, fingers and toes requiring amputation, early signs of cancer, early-stage lupus. Yet laboratory monkeys had been given doses of the drug 500 times that given to the human volunteers without such side effects. Now, many agree that this disaster could have been avoided by using advanced technology, microdosing. Microdosing involves giving tiny, safe doses of new compounds to human volunteers, and samples of blood or urine are then analyzed by accelerator mass spectrometry, or AMS. Able to count individual atoms, and so sensitive it can detect a compound even if just 1 liter of it were diluted in the world's oceans, AMS can show how compounds have been absorbed, distributed, metabolized and excreted by the human body. The European Union Microdose AMS Partnership Programme recently demonstrated microdosing as 80% predictive of drug absorption and distribution in the human body, making it significantly more accurate than primate, dog, and rodent models. Adoption of advanced techniques such as this would allow drug development to be accelerated, accuracy improved, and costs cut. And this is not the only modern technique ready to replace the use of primates. Others include cell and tissue culture models, the latest microscopic techniques, sophisticated computer and mathematical modeling, three-dimensional tissue engineering, and high-tech scanning. After commercial testing, the next largest area of primate use is academic neurology experiments in universities. These studies can involve restraint, brain damage, and electrodes permanently implanted into the animals' heads. Often this so-called fundamental research does not attempt to justify itself by describing a clear application for human benefit. Yet advances in modern scanning techniques are enabling non-invasive neuroimaging of the human brain, providing unprecedented understanding of mental ill health, neurodegenerative diseases, vision, hearing, speech, pain, and more, by providing data of direct relevance to patients. There are no regulatory requirements for academic experiments, so this is a field where replacement with modern scanning techniques could be rapid. Industry and regulators, and indeed much of academia, are inherently resistant to changes in the established system. But the reality is that animal testing is a poor predictor of human responses. Commercial testing is a huge area of primate experimentation, but a comparatively small part of the overall testing for new drugs. So replacement should be faster than with the EU cosmetics testing ban, where a start-to-finish test replacement strategy was employed. Primates come at the end of the testing program as the second mammal required by regulation. By the time the monkeys were being strapped into restraint chairs at Huntington Life Sciences, hundreds, even thousands of smaller animals would already have been experimented upon to test the same product. If regulators are serious about replacing animal testing with advanced technology, it's vital that the animal tests be ended earlier and that testing move to human-based methods as quickly as possible. It is time for a real commitment to end this suffering and set targets to ensure progress, as has been done with CO2 emissions. Or do we think that these crude and cruel tests are as good as 21st century science can get? We are primates too, and we do know better.